Welcome my dear friends. In this video we are going to be looking at Varignon's theorem. Varignon's theorem is one of the popular theorems which deals with moments. It can also be called as principle of moments or law of moments. Let us go with the statement. If many coplanar forces are acting on a body, then the algebraic sum of the moments of all the forces about a point in the plane of the forces is equal to the moment of the resultant about the same point. For a better understanding, let us move to another page. Here we have to understand two things. What is moment and what is coplanar forces? And moment, of course, you people know what is moment. It is a twisting force which can be given by the product of the force's intensity and the perpendicular distance between the point where the moment is required and the line of action of force, right? And probably hope that you all know the definition and the formula for finding moment, right? And we have to understand what are coplanar forces. If some number of forces acting on a body are lying in the same single plane, like this is x-axis, y-axis, and this is z-axis. If a two-dimensional area is created by any two axes like this, so this is the area which is created by the two dimensions, that is in x direction and one is y direction, vertical and horizontal. So the plane is created, like a two-dimensional plane is created. If the forces are lying in the same plane and not going beyond that plane, let the force might be in different directions, but all the forces which are acting on a body are lying in a single plane, and the forces which are lying in a single plane are called as coplanar forces, which is nothing but the forces which are containing in the same plane, that is nothing but coplanar, right? Yes. Suppose we have some forces being acted on a body in this direction. Suppose I am taking a body. See, for example, on this particular body, if number of forces are being acted on this body, suppose let us say in this direction, in different directions with different magnitudes, forces are being acted on this body, right? So with the application of all these forces, this particular rectangular body will obtain a new force, which is nothing but resultant. You all know that we have also given a lecture on this resultant in our previous videos, right? So with the application of all these forces, the object will attain a new force, which is nothing but the resultant. With that resultant force, the body starts moving, and if the resultant is having a definite direction, so the body starts moving in that definite direction, and that is nothing but the direction of the resultant. You all know what is resultant is. In order to find out the resultant for these many forces, we have used a formula, we have used a process, like we have resolved the forces into two components for these kind of forces which are inclined, and we have taken forces directly which are horizontal or which are directly vertical, and we have derivated one formula, R equals to sigma h square, which is nothing but all the horizontal forces summation square plus sigma v square, the summation of all the vertical forces. The vertical forces may be act in upward direction or they may face towards down. If the forces are facing towards down, they are taken as negative. If the forces are moving up, they are taken as positive. Same in the case of horizontal forces. The forces moving towards right are taken as positive, and which are left taken as negative. So with all those sign conventions, we will try to add all the horizontal forces and all the vertical forces, and we will somehow find the total resultant. So the resultant comes out to be an integer or some value. So that value, it is nothing but the newly obtained force by an object, right? And let us move to another page. Yeah. For example, let us take a lever on which some different forces are being acted. So there is a lever like this on which some different forces are being acted. One force, F1, acting at a distance of x1, it is x, and the point where it is fixed is called A, and the point which is left freely is B, and F1 is the force which is acting at a distance x1, and we have another force F2 which is acting at a distance of x2. Let us take another force maybe, and this force is acting at a distance of x3 and f2, and this is f3. You can see three forces are being acted on the lever, which can certainly create a rotational effect here at this point, which is, see, with the application of this kind of force, what happens? Will the body rotate in a clockwise direction or in the direction of anti-clockwise direction? Let us see with some animations. I will switch the tab. Here we can have some animations. See, you can see the same lever there, right? So with the application of this kind of force at this particular point, which is at a x1 distance from this point, so what happens with the point with the forces application? So you can see the gradual deformation. So this is how the body starts moving. Since this point is fixed and the point B can be freely moved, with the application of any force it can freely move. But point A, it is fixed, it will only have the turning effect, right? It will only have the turning effect. So you can see the deformation. And can you tell me what is the direction of the rotation? It is in clockwise direction, which can be taken as positive moment, right? Here it is positive moment. Let us switch to our board. See, with the application of all these three forces, which are similar in their direction but can be varied in their magnitude, right? All these forces can create moment at this particular point A. See, all the forces are having their magnitudes and the distances, right? So each force can create a moment. And see, when so many forces, like 3 or more number of forces are being acted on a body, the body will obtain a new force called resultant, right? So F1, F2, F3 will also have a resultant when these three are acting on the same body at the same time, right? So that force which is coming out newly, it will create a force at somewhere, I don't know what is the location. So with the summation of all these forces, when we try to find out the resultant of all these forces, it will give the final force, right? It will give the final force, which is nothing but the resultant force. And the resultant force is also acts on the same lever. We don't know where it is being acted. Let us say it is at x distance, right? So according to the statement, F1 is the force which can create moment, which can be written as F1 x1. It is the intensity of moment. That is nothing but moment 1 with the force 1. And F2 x2, it is the moment created by force 2. It can be moment 2 plus F3 x3. It is the moment created by the third force, that is moment 3. According to the statement, the individual moment created by each force, if the algebraic sum of the moments created by each force is equals to the moment created by the resultant of the forces. See, here we have F1, F2, F3. All these three forces are being acted on the body. So all these three forces will definitely have a resultant, and that resultant is also acting on the body. So the summation of all the moments is equals to the resultant force into its distance. So this is nothing but the moment created by the resultant of all these forces, F1, F2, F3. Here I have added all the forces without mentioning any negative sign. Since all the forces are acting towards down, which are making a clockwise direction, I have taken all of them as positive. If any force is acting in the reverse direction, like let us say, fine. Let us take this force out, and let us say it is acting in this direction, which is opposite. With the application of these kind of forces, can you tell me in what direction does the lever starts moving? And let us go with the animations again. See, with the application of these kind of forces, the body starts moving in, you can see it is in anti-clockwise rotation, right? With the application of this force, the body started moving in anti-clockwise direction, which is a negative moment, which can create a negative moment at point A. So, if the force is acting in the opposite direction, it can be mentioned with negative F3x3, which is nothing but anti-clockwise moment, right? So all this is equals to the moment created by the resultant of the forces. It is nothing but the statement is telling. It is the thing that statement is about to convey us. Let us go to the statement. If many coplanar forces are acting on a body, then the algebraic sum of the moments of all the forces about a point in a plane. Here we have our point as it is point A, where we obtain all the moments created by the individual forces, and we can obtain the same moment of the resultant above the same point. So let us go with some more brief explanation. See, you can see the figure. I will pinch it somewhere. Yes. Here from the figure you can see each force is contributing its force in creating some moment at point A, right? According to the statement, what happens is all the forces, see F1, F2, F3 will have, if they were combined, what happens is the resultant will come. That resultant will act the same lever. If I am replacing all the F1, F2 and F3 forces in a single force, that may act in this direction or opposite direction. If all the forces are acting in the downward direction, the force can also be represented in this direction. So this force is nothing but it is the combination, it is the resultant of all the forces F1, F2 and F3. So that resultant is also being acted on the same lever. They are not acting separately. I have combined all of the three forces and I am representing all the three forces in a single force, which is called resultant, right? So this resultant is acting on the same lever, and we don't know what is the distance, at what distance does that resultant is acting from point A. So the distance I have assumed it as x. According to the statement, if many coplanar forces are acting on a body, then the algebraic sum of all the moments in the sense the moments created by F1 plus the moments created by F2 plus moment created by F3, that equals to the total resultant of the forces, which is nothing but R, into the distance where it is acting. It is the moment created by its resultant, right? So this is nothing but called Varignon's theorem. We have taken only three forces here for the explanation. If suppose there are three or more number of forces are acting, it can be F1, X1. Like, let us go to the previous page. Here I will repeat all. If many forces like this, see, here we can see 5 different forces are acting in different directions, like upwards and downwards. So with the application of all these forces, a new force is created. So here we have 5 forces. So it can be F1, X1 plus F2, X2 plus F3, X3 plus F4, X4. If it is so on with number of forces, it can be plus so on up to Fn, Xn. That equals to resultant of the force multiplied with the distance where it is acting from the point A, right? From point A. This is nothing but the moment created by the resultant of all these forces, right? Hope you have understood, and we will be solving problems on this in our next video. Thank you so much.